In this video, I'm going to be sharing the 10 most commonly missed basic navigation questions from the FAA written exam. Now, when we're talking about basic navigation, we're talking about things like how to use Zulu time, how to use latitude and longitude to find your position on a map, and also how to use the VFR sectional for navigation. And surprisingly enough, there are quite a few questions that will eat your lunch on these topics on the FAA written exam. So let's take a look at those and see what they are so you can master that test. Now, for those of you who haven't been following this series, I'm able to get this data by looking at the results from the quizzes in my premium private pilot ground course. And I can actually see the most missed questions on each topic. So what I like to do is to take the 10 most missed questions on each topic and throw them into a quiz of the day and post that quiz here on YouTube. So if that sounds cool, be sure to keep an eye out for the next quiz of the day so you can participate when that comes out. It's totally free and you don't have to sign up for anything. Now for this quiz, I had 133 people participate, and as you can see, the average score was 4.62 out of 10. This means that these folks on average scored a 46% on the quiz. Not good. So let's take a look at each one of these questions and see how well you do. Question 1. If an airplane departs from an airport in the Eastern Daylight Time Zone at 8:15 EDT, then flies for 3 hours and lands at an airport in the Central Daylight Time Zone, what would be the landing time in Zulu? In just a minute, I'm going to show you the most common answer for this question, but one of my viewers asked if I can start showing you the questions first without the results so you guys can have a chance to solve these before I explain the answers. So I'm going to try that in this video. Let me know if you guys like this better, and I'll keep doing it this way if you prefer that. Okay, now that you've had a chance to solve this, let's take a look at the most common answers. You guys did pretty good on this one, but almost half of you missed it, so let's take a quick look at why the correct answer is 1515 Zulu. It looks like there really isn't a commonly picked wrong answer on this one, so I'm thinking that a few of you guys just don't know how to solve it. So let's look at how to do that really quick. Now, the question says that we need to look at figure 27. You don't actually need to if you're really familiar with the time zone, but there's no reason to take a chance if you're taking the written exam. So just pull out the figure. It's literally a cheat sheet. Let's see, our takeoff time is 0815 Eastern Daylight Time, and then we flew around for 3 hours, so our landing time would be 11:15 Eastern Daylight Time, wouldn't it? Because 8:15 plus 3 hours equals 11:15. So all we have to do is to convert to Zulu time, and this is super easy. All we have to do is look at figure 27, where the FAA basically gives us the answer here. Remember, Zulu time is basically just a slang word for coordinated universal time. So all we have to do is look at this chart in the lower left-hand corner of figure 27, and it literally tells us what to do here to get our Zulu time. It looks like for Eastern Daylight Time, all we have to do is add 4 hours. So 11:15 plus 4 hours is 15:15 Zulu. So we're landing at 15:15 Zulu. That's how easy this is, guys. All right, next question. How far are you north of the equator if you're at the following coordinates? North 51.8486, west 00.5545. Now, I'm going to be honest with you, I'm not sure that this one's going to be a question they ask you on the test, but I came up with this question because it teaches you the basic premise of latitude and longitude. And if you can understand this basic concept, you'll be able to use all the other aspects of latitude and longitude. So I think it's super important. All right, let's see if you got the right answer on this one. Wow, I'm really surprised to see that a majority of you guys got this wrong. Almost 44% of you guys thought the correct answer was 5,184 miles. Quite a few of you thought it was 51 miles, and I can see why you might have thought that since we're at the 51st parallel, but that's not quite how this works. Let me show you how it works really quick. Before I do want to mention that determining lat long can be kind of tricky because you first need to determine what format your coordinates are in. But it really doesn't matter for this question. You'll get the right answer no matter what format you use. This particular format is decimal degrees, which means that these numbers right after the main degree coordinates are a percentage of a degree. But you could see them like this, where the coordinates are in degrees, minutes, and a percentage of minutes, or like this, where they're in degrees, minutes, and seconds. I'm not going to explain all these, but I'll just show you the basics really quick. First things first, the most basic thing to know about latitude and longitude is that 1 minute of latitude equals 1 nautical mile. This is actually why we moved to knots in airplanes over the last 40 years over miles per hour. It makes it easier for us to calculate things. Anyway, 1 minute of latitude equals 1 nautical mile, and inside each degree of latitude, there are 60 minutes, literally just like a clock. So, if there are 60 minutes, there are 60 nautical miles in each degree. This means that we can simply take this 51 degrees north and multiply it times 60 to get a rough distance from the equator. So let's see, 51 times 60 equals 3,060 nautical miles. Really, we could stop right here and see that 3,100 miles is going to be the right answer. But let's take this a little further so you can get a clearer picture. If these coordinates are 0.8486% of 1 degree of latitude, then we could just multiply that times 60 because 1 degree equals 60 minutes. So we're roughly another 51 nautical miles north of this position. So we could just add 51 to 3,060 to get a total of 3,111 nautical miles north of the equator. Now, if these coordinates were degrees, minutes, minutes, then these coordinates would actually look like this. So you can see that this format actually makes it easier since 1 minute equals 1 nautical mile, which means that we could just add this 50.916 miles to our 3,060 miles to get the same result. Now you could see seconds, which would just show 55 seconds instead of the 0.916, and that's just 0.916 times 60 because there are 60 seconds in 1 minute. Not too many people use seconds, but there are a few. So if you need that, that's how you do it. Now, one other thing I want to mention is that this doesn't work quite so well for longitude as it does for latitude because of something called convergence. That simply means that the lines of longitude get closer and closer as you get closer to the poles. But the premise is basically the same other than that. Okay, next question. At what altitude is the top of the lighted obstacle 7 miles from the SAV Vortac on the 230 radial? See Figure 23, Area 3. Now for this one, you do have to use the figure. And by the way, you can download the FAA's testing supplement for free from the FAA's website. And that has all these figures in it. I personally recommend buying the paper version of this from Amazon though. It's not very expensive and it makes things a lot easier when you're practicing for the actual test. I guess you could just print them off too if you're looking to save a buck, but either way, having paper is much easier for the questions where you have to plot stuff. Okay, let's see how you guys did. It looks like 44.5% of you guys got this right, and a bunch of you thought it was 1,545 feet MSL. But if we zoom in on figure 23, I can see why you guys thought that. 1,545 feet is directly under that obstacle, but that altitude is actually for this tower over here. Sorry, guys, the FAA is never going to pick easy examples for some reason. You just always have to be on your toes because the altitude on this tower is kind of hidden directly above it. And we know that this is the correct altitude because there's nothing else around it over here. This 1,545-foot altitude is for the big one in this group down here. And that raises an important point, guys. It's super important for you to take your time on this test. It's important to double check and make sure that you're not missing something because they will try to trick you at every opportunity possible. And every wrong question adds up, and that can be the difference in passing or failing the test. All right, fourth question. Which navigation symbol is indicated by a single dot inside a hexagon with tabs on 3 of the sides? What do you think? Pause the video if you need, and I'll show you what everyone else thought. 57% of you guys got this right. A vortac is the correct answer. Now, to make things simple, this is the symbol it's talking about, and these are the tabs the question is describing. A VOR is only a hexagon, and a VOR DME is a hexagon with a rectangle around it. A lot of you guys thought it was a VOR DME, but that's not the right answer. A vortac is a TACAN and a VOR combined. So this symbol is kind of a hybrid between the TACAN symbol, which has tabs, and the VOR. But the DME symbol is just a rectangle. So if you throw a rectangle around a hexagon, that gives you the VOR DME symbol. Okay, next question. If an airplane departs from an airport in the Central Daylight Time Zone at 0730 CDT, then flies for 3 hours and 20 minutes and lands at an airport in the Eastern Daylight Time Zone, what would be the landing time in Zulu? Once again, use figure 27 as necessary. This is another one that's pretty simple. You guys did a lot better on this one. It looks like almost 67% of you guys got it right, but I'll go over it really quick so no one else misses it. Once again, they ask you to find your landing time in Zulu, so I really don't care that I landed in the Eastern Daylight Time Zone. I'll just start with what I know. I know that I took off at 0730 and flew for 3 hours and 20 minutes. So that means I landed at 10:50 in the time zone I took off from. Let's see, that was Central Daylight. So all I have to do is pull out my chart on figure 27. And for Central Daylight, I just need to add 5 hours to get over to Coordinated Universal Time or Zulu. So I'll add 5 hours to 1050. So our land time in Zulu is 1550 Zulu. Too easy. Okay, question 6. If you were flying into Savannah International Airport and were 16 nautical miles from the field on the 345 radial, what would be the easiest way to tell Savannah approach your position when you initially call them up? See figure 23, area 3. Now, for this one, you're going to have to use the figure. If in doubt, always look at the figure. It never hurts to get more details on what they're asking you. Before I show you this one, let's look at what everyone said. Some of you guys thought you should tell them that you're on the 345 radial at 16 nautical miles. And that's totally fine in most cases, but the question actually tells you to give you your position in the easiest possible format to ATC. Let's look at figure 23 and see how we could do that. Now, if you take your time to plot your position, what you'll find is that you're somewhere right here on the map. And what's something around here we can use to identify our position? Yeah, this little red flag. This is what we call a VFR reporting point, and this particular point is the town of Springfield. And if you tell ATC that you're over the town of Springfield, they're going to know exactly where you are. If you told them that you were over the town of Guyton here, or Goyton, however you say that, they may or may not know where you are, but they are required to know where these VFR reporting points are. That's part of their job, so use these whenever you can, because it makes your radio calls much shorter and cleaner when you use them. Next, we have question 7. At what altitude should you fly if you want to clear the group obstacle east of Sulphur Springs Airport by 1,000 feet? See figure 24, area 5. Let's see what you've got, and I'll show you the answer. Okay, much better on this one. It looks like 60% of you guys got this right, but that's still 40% of people missing this one. Some of you thought that the correct answer was 1,919 feet MSL. Let's take a closer look at figure 24 and see why you thought that. Basic directions got a lot of you guys. The question is asking about the group obstacle east of the airport. Over 20% of you guys were looking over here at this obstacle west of the airport. Don't answer these questions too quickly, guys. They will bite you. Then some of you saw this group obstacle down here southeast of the airport, but I guess you missed this one directly east of the airport that has a top of 811 feet MSL. And all we have to do is add 1,000 feet to that to get an answer of 1,811 feet MSL. Take your time on these questions, guys. A lot of them aren't that hard. You just have to think for a second before you just jump in and answer. Okay, next question, number 8. According to the VFR sectional in figure 20, area 5, what would be the lowest safe altitude to fly over the blimp hangars near Elizabeth City Coast Guard Air Station? Pause the video for a second if you need, and I'll show you the answers here. Okay, looks like most of you guys got this one right. Some of you thought that we could fly at 1,234 feet MSL. So let's take a look at figure 20 and see why we want to fly much higher than that. Now, this is a little bit of a trick question. There really isn't anything inherently dangerous about flying over the blimp hangars right here. But if you'll notice, there's a GPS waypoint right next to those with a little note down below it. It says that there also could be an unmarked balloon on a cable up to 3,008 feet MSL, so be sure to check the NOTAMs. Now, if this were me, I'd want to give myself a little bit of a safety buffer because I don't know exactly where these are or even how many of them there are. 500 feet above those balloons is a good starting point in a situation like this, so we can just add 500 to 3,008 feet to get 3,508 feet MSL. Too easy. Once again, I think a lot of you guys missed this because you jumped on the most obvious answer too quickly. If something seems too easy on the test, it probably is. Just take 10 extra seconds to reread those questions and look at the figures before you answer the question. That's the biggest piece of advice I can give anyone taking the FAA written exam. All right, question number 9. Use figure 21, area 3 to determine the approximate coordinates for Washburn Airport, 5 Charlie 8. All right, if you want to try to solve this, be sure to pause the video, but for everyone else, I'm going to dive right into the answers. Almost 55% of you guys got this right, and the rest of the answers are pretty even, so I think the people who missed this just didn't know how to solve it. So let's take a quick look at how to do that. First, we had to find Washburn Airport, which is down here in Area 3, and then I always like to start with latitude, so let's see roughly where we are. The closest latitude I see is up here at 48 degrees north. Now, you have to use a little bit of common sense to determine that you're in the northern hemisphere, but we're in the US, so that's pretty obvious. If we were south of the equator, that would be 48 degrees south, so remember that if you're ever flying down there. Okay, so then we see another big line of latitude down here, and the important thing to know is that on a VFR sectional, they actually draw you a line at the 30-minute mark as well as each individual degree of latitude. That means that this line right here is not 47 degrees north, it's actually 47 degrees 30 minutes north. So then we can come down here and count the individual minutes below this mark. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes. So 9 minutes below 47 degrees and 30 minutes. So we can just subtract 9 minutes from 30 to get a latitude of 47 degrees north, 21 minutes. Now let's find the longitude. Well, that's too easy. We're literally 1 minute west of the 101 degree marker. So we've got 101 west and 1 minute. So you can see that north 47 degrees, 21 minutes, west 101 degrees and 1 minute is our answer. Okay, here's our 10th most missed question on basic nav when it comes to the FAA written exam. And I'm noticing a trend here. A lot of you guys are struggling with Zulu time, and this isn't something that just goes away after the written exam. So I really recommend that you guys focus on this topic a little bit more. You'll thank yourself later if you do. So let's take a quick look at that last question. If an airplane departs from an airport in the Central Daylight Time Zone at 0900 CDT, then flies for 2 hours and lands at an airport in the Mountain Standard Time Zone, Arizona, what would be the local landing time? Use figure 27 as necessary. Okay, I'm going to tell you right now that this is a tiny bit of a trick question because Arizona is one of like 2 states that does not celebrate daylight savings time. And that's what it is, a celebration, because these dingleberries are not joining in on the fun for some reason. And that just makes it harder for everyone else. But anyway, let's take a quick look at this because over half of you guys missed this question and I hate that. Let's get you straightened out really quick. We know that we took off at 0900 Central Daylight and flew for 2 hours. This means that we landed at 1100 Central Daylight, but that's not what the question is asking. It's asking us for Mountain Standard Time. Well, there you go. They straight up told you that these dingleberries don't celebrate daylight savings time. So you could use this chart in figure 27 to convert to Zulu and then over to Mountain Standard if you want. But you won't always have this fancy chart with you, so this is what I like to do. Start with our land time of 11 Central. Then we went from Central to Mountain, so we lost 1 hour. So subtract 1. But then we fall back because daylight savings ends in the fall. So we fall back 1 hour, so we have to subtract 1 more hour. So our land time was 11, minus 1 is 10, then minus 1 more is 9. We're landing at 0900 in Arizona time. What a special state. And this is the real reason why most pilots use Zulu time. You don't have to worry about states that are retarded or states that are cut in half by time zones. You can just always fly on Zulu time. Living on Zulu time. You're welcome for that, by the way. Now, this video wouldn't be possible without the folks that have already purchased and used my premium private pilot ground course. So I want to thank you guys for doing that. I don't know of any other ground course out there that takes the 10 most missed questions and walks you through those. And at a fraction of the cost, I might add. My premium ground course is only $50, so I'm hoping to bust into the market and force all these schools that are ripping you guys off to lower their prices. $300 for a ground course is absolutely retarded. So please pass the word along that this ground course is here and it has everything you need to prepare you for the written exam. Thank you guys for watching, and I'll see you in the next episode. See ya. Living on Zulu time. Living on Zulu time. Well, you know that I've been through it. I'll set my watch back to it. Living on